Hello, everybody, and welcome back to Why Slice. We have talked about computer science, what computer science is, the Wyoming computer science domains, and I have given you a little bit of insight into where computer science is used in my research, but also in other people's research that I'm collaborating with. Let's have a look at some real world examples of where computer science is used now. And there are the obvious things that you're already aware of. At the moment, you're using software, you're using computer science to watch this video. I use software and computer science to record this in the first place. And I uploaded this via the internet that allowed you to download it and now view it. I don't really want to talk about that because a lot of that stuff is really obvious. Instead, I want to talk about something where it's not entirely as obvious, but also something that is closer to home for me because it is more related to the research that I do in artificial intelligence. And a great example of an application domain of computer science and artificial intelligence is logistics. Imagine, for example, that you're running the post office and you need to make sure that all the packages are delivered and all the letters are delivered, cost doesn't become too high. You don't have to wait ages for something to arrive, and you can drop this off at a reasonably convenient location. There's actually a lot involved in making all of that happen. And of course, traditionally, this has been the domain of expert humans that have been designing these processes in a way to work this smoothly. But what we're increasingly finding is that as more and more people want to use, for example, the post office, these problems that we need to solve to make all of this happen become larger and larger. And this is really where computers come in and where computers can help us. So, at its core, there are a bunch of different things that need to happen for you to get the letter from your aunt in the mail. Your aunt needs to post it, but then it needs to get to where you live, right? So this involves taking your letter and loading it on a truck and maybe on a plane, maybe even on a ship. It has to pass through various hands until eventually it is delivered by hand to your house. And there are a lot of different and difficult optimization problems that we need to solve in order to make this happen. For example, the assignment of who's going to actually going to deliver your letter and what plane is it going to be on, what truck is it going to be on. Lots of different choices because the postal service obviously has lots of resources, lots of people working for it. How do we make this assignment happen? We can't simply try every possibility because that becomes really, really large, really, really quickly. Even if we're only talking about a single post office in a reasonably sized town in Wyoming, which is not that large, even there, we're solving relatively difficult problems. And this is where a lot of computing comes in practice, because on one hand, if we want to solve these problems using computers, we need to have the computing power available. This might, in some cases, for large and difficult problems, involve something along the lines of the research computing facilities that we have available at UW, or maybe something smaller. Maybe you can solve a particular problem on your laptop or even on your phone. But then it also involves developing the algorithms, in particular, in this case, developing the artificial intelligence approaches that allow us to do this in the first place. And then once we've developed that, we need to go and implement them. For this, we need programming languages. We need people who know how to use these programming languages, how to express something that we have developed and designed in an abstract form as an algorithm. If I get a letter from there, then it goes onto this particular truck. How do we tell a computer about this? And then, last but not least, even once we have solved the problem, how do we then put this into action and tell the people at the post office what exactly they need to do? What letter needs to go into what box, and then what box do we put on the truck, and what box do we put on the other truck? Or maybe we want to forward this on and get it onto a plane or a ship. So the interpretation of a solution in a way that the post office employee can then actually do something, knows what to do, in a reasonably simple manner because we don't want to know about the entire problem that was solved behind it. I want to deliver this letter here. I don't care about the millions of other letters that are already being delivered as well. I want to focus on my tiny part of the problem, and that needs to be presented in a way to me that this makes sense and that I can actually do it. So lots of things going on behind the scenes with computer science in many, many real world applications. This is, of course, only one particular example, motivated by my background in artificial intelligence, because solving these types of problems are also some of the classical problems in AI that have been around for decades and that people are still working on. We're now getting to a stage where computers are in some cases better, in other cases still not as good as human experts, but we're working on this until eventually we can do all of this automatically, which hopefully means that we can optimize even more and that you will be able to get your letters faster. Maybe not your letters, because of course we have email now, another application of computer science in the real world, and something that obviously has a really, really large impact because this completely solves the problems that I've just talked about. I just press a button and you have the email immediately. No post office involved in that. I don't need to worry about how do I deliver this particular email, what truck do I load this on? Doesn't even make sense anymore. But packages, at least at the moment, we have no technology that would really allow us to replace packages. So this is still something where this is important. And apart from that, there are lots of other applications where computing and computer science is important in practice.